Hello and welcome back to the Math and Physics Coach channel. In this video, I will be covering these 4 example problems on limits. For problem 1, and for any time when we're asked to find the limit, the first thing we want to do is plug in the limit we are evaluating to and see what we get. When we do this in the first problem, we can see right away that we can solve tangent of pi over 4 to get 1. So the limit of tangent of x as x approaches pi over 4 equals 1. For problem 2, we are again going to plug in t equals -3 into the function, getting -3 plus 3 over -3 squared plus 9. This can be evaluated to get 0 over 9 plus 9, or just 0. For problem 3, again plugging in x equals 3, we'll get 3 cubed plus 4 times 3 squared minus 9 times 3 minus 36 all over 3 minus 3. If we evaluate this out, we will get 0 over 0, which is an indeterminate solution. There are many different examples of indeterminate solutions, such as 0 over 0 or infinity over infinity. When evaluating a limit that leads to an indeterminate solution, we are then able to use L'Hopital's rule. If you are unfamiliar with indeterminate solutions or L'Hopital's rule, you should review lessons on those. To summarize this rule, when you have an indeterminate solution, you can take the derivative of the numerator divided by the derivative of the denominator and then evaluate the same limit again. When we evaluate these derivatives, we'll get 3x squared plus 8x minus 9 over 1. Now, evaluating the limit of this function as x approaches 3 will lead us to 3 times 3 squared plus 8 times 3 minus 9, eventually leading to 42. For problem 4, we'll again start by substituting t equals 0 to again get an indeterminate solution. We'll apply L'Hopital's rule again to this function, and I will rewrite this function using the 1/2 power instead of the square root. To evaluate this, we'll use the power rule on this function, which will get us 1/2 times 9 minus t raised to the minus 1/2 times the derivative of 9 minus t, which is -1. The derivative of -3 is 0, and this will all be over the derivative of the denominator t, which will be 1. This can be simplified and rewritten to get -1 over 2 times the square root of 9 minus t. At this point, we will evaluate the limit again by substituting t equals 0, getting -1 over 2 times the square root of 9 minus 0, or -1 over 6. That's it for this video. Thanks for joining, and be sure to subscribe if you want to see more examples or to request any examples that you'd like me to explain.